In question 8a, we must find out how much money Olga ends up with 5 years after depositing €3,000 in a bank account. To solve this, we use the compound interest formula. The initial value, P, is 3,000. The interest rate, I, is 2.4%, which is 0.024 as a decimal, and the time period, T, is 5. We get to our answer by using our calculator and then rounding to 2 decimal places. In BI, we must explain what is meant by the present value of a payment of €1,000 in 1 year's time. Simply put, it is the amount of money you will need to invest right now to end up with €1,000 in 1 year's time after adding interest. In BII, Chen ends up with €4,000 in an account after 6 years. We need to figure out the value of this starting investment. We'll use our compound interest formula again. This time, the final value, F, is 4,000. The interest rate, I, is 0.024. And the time period, T, is 6. To find P, we should divide both sides of the equation by 1 plus 0.024 to the power of 6. From here, we use our calculator and round to 2 decimal places. In C, Fiona makes quarterly payments for a loan that has an annual percentage rate of 2.4%. We must find the equivalent quarterly interest rate. It will help to work with concrete numbers, so let's imagine we invest €100 for 1 year. Since there are 4 quarters in a year, after 4 compounding periods, the €100 would grow to €102.40. Putting this into the compound interest formula tells us that 102.40 is equal to 100 times 1 plus I to the power of 4. To solve for I, we divide both sides by 100, simplify the left-hand side with our calculator, take the 4th root of both sides, subtract 1 from both sides, simplify the left-hand side with our calculator, convert to a percentage, and then round to 2 decimal places. In DI, Rowan is making a monthly deposit of €1 into a savings account each month for 36 months. We must express the final amount in terms of a geometric series. The interest rate is 0.11% per month, which is 0.0011 as a decimal. Using the compound interest formula, investing €1 for m months will have a value of A times 1.0011 to the m. The first payment is invested for 36 months, the second payment is invested for 35 months, the third payment is invested for 34 months, and so on. The second last payment will be invested for 2 months, and the last payment will be invested for 1 month. This information can be used to find the final value of each of our payments, and to find our total amount, we simply add together all these values. In part II, we need to find the value of A that will result in having €12,000 in the account after the 36 months. To begin, we set the expression we obtained for the total amount equal to 12,000. Then, we factor out the common factor of A from the right-hand side. Next, we apply the formula for the sum of a geometric series. Here, the first term, A, is 1.0011, the common ratio, R, is 1.0011, and the number of terms, N, is 36. From here, we divide both sides by the value of this sum, then use our calculator and round off to get our final answer. In E, a park sells 3 types of ticket. We are given the expected value of the price of a ticket, and we must use this to find out X, the price of an adult ticket. To find an expected value, we begin by multiplying each price by the corresponding percentage. For the child ticket, we get 11 times 52%. For the student, we get X minus 5 times 15%. And for the adult, we get X times 33%. The expected value is equal to the sum of these 3 terms. We can rewrite the percentages as decimals, multiply out the brackets, combine like terms, subtract 4.97 from both sides, and then divide both sides by 0.48. This tells us that X is equal to €18.50. In part F, we are told that a shop sells an item for a margin of 18%, and we must find the markup. It's useful here to work with concrete numbers, so let's assume that the selling price was €100. The margin being 18% implies that the profit would be €18. The cost price is the selling price minus the profit, which comes out as €82. To find the markup, we divide the profit, 18, by the cost price, 82. Written as a percentage, correct to the nearest percent, we get a final answer of 22%.